Ludwig, what is a virtual factory?
Well, there is a very simple answer, and that's a digital representation of a real factory. But what's digital in that sense is that one can integrate many different forms of information from different sources. For instance, the layout of a factory, the operation of machines, the reconfiguration that in many situations is happening all the time. In some factories it is a daily exercise. In others it's something happening every few months when a new product comes online. And all that integrated in a digital representation that the different players in that can relate to with a very high quality visual representation. That's basically what we're talking about.
Now, I'm being a fan of Nvidia's Omniverse platform. Where does that fit into the virtual factory?
Well, Omniverse is our platform, as you said, for integrating these different data streams. And if you look at many traditional manufacturing operations, factories, there are very different kinds of data streams that need to be combined. It is visuals from cameras. It is 3D designs from CAD and computer-aided engineering products. It is live data fed into the system from robots acting along a production line. And to integrate all that in a meaningful way in one visual platform is one key feature of Omniverse. But combined with that, we can integrate AI-based analysis of environments, of operations that will allow for a more fluid decision-making of the participants in this. So that's essentially what Omniverse offers.
And you mentioned AI. Now, obviously, AI is flavor of the month for the past, probably 18 months at least, and generative AI. If I may, given all you're doing with AI, Gen AI, do you see that playing a bigger role today? Or are people using this in production already, or is this something that still kind of people are trying to get their heads around how it'll help them?
Well, obviously, there's a lot of talk about it, but there is also a lot of activity around making it more easily useful and useful in established, if I can call it that, production environments. And again, that has to do with the types of data that are needed and that are used for such operations, where AI technologies can be used to analyze such data. And so we are offering lots of tools that users can deploy to combine the capabilities of an AI based on a large language model with the proprietary data that come out of their production systems, and to maintain their propriety, if you want, or make sure that these data, which are used for training and retraining of such AIs, stays within the boundaries of the owner of the company.
One of the things I'm seeing a lot right now is, you spoke about training the models, large language models. People are trying to put small language models, as you say, keeping the data at the edge.
Yes.
I'm guessing the role of what we know as the edge over the past the last decade, that's getting more advanced. There's more compute, more AI coming down to the edges, right?
That's absolutely right. And it obviously has to do with the power of the compute capability that is available at the edge now, but also the continuity of data formats, of capabilities between the edge and ultimately the AI factory that is behind it and supporting it. As far as the edge is concerned, obviously there are some kinds of AI-based analysis that are much more easily processed directly at the edge. Think of vehicles moving about a factory floor. They need to analyze their surroundings. They need to act based on, let's say, obstacles along the way. They need to understand where they are operating inside a real factory, and to make that more efficient, much of that can take place at the edge.
Now, if I may, you mentioned obviously you're bringing lots of different data streams together, and people will understand, as you say, you have the design, you have the IT/OT data, you have all sorts of data coming in. In terms of standards, Nvidia has been one of the pioneers behind OpenUSD. Where does OpenUSD fit into all this?
Well, when you have data coming from different sources, and we were there a couple minutes ago, they need to be standardized to the point that they can be presented in a coherent way. And OpenUSD is one of the standards, the most important one perhaps, that we have deployed in Omniverse, because it allows data from different sources to be used in describing and visually representing the objects in such an application. For instance, coming from the factory floor, the designs, the movements, the accurate physical representation or physically correct movements of robots, of people actually. And so that's where you need scenes, as the computer scientists say, that represent them on screen or in an HMD. Now that's for the objects, their exact measurements and physical capabilities. Another standard, by the way, that is also implemented is called MDL, and that relates to the materials that are on the surfaces of these objects, and you want them to be physically accurate, for instance, to reflect light properly as the material does in a physical environment. And that's an important aspect of making design decisions based on digital representations of products.
Yeah, as you say, when you're training the robot for the AGV inside in this environment, it has to believe that it's in the real world. So this is where the mapping the real world almost photorealistically and having a standard that everybody talks the same language is key, right?
Right. And these standards have to be open so that others can easily access them and use them as they build further applications using such data that we feed into Omniverse.
The last time we met up in Berlin, we were chatting particularly about the automotive industry. Given what you're seeing today, what industries are taking advantage of this type of technologies with virtual factory?
Well, automotive was probably in the lead originally, or they were the first ones to adapt that, because they have for the longest time already used a lot of the technologies to integrate visual data and visual representations of products into their design process. So they had a head start, but there certainly are others. So for instance, logistics, wherever you are maneuvering around in a warehouse, for instance, there are still lots of inefficiencies involved in that. And as you deploy robots, for instance, to handle products in a warehouse setting, they can optimize product flows a lot and thereby take time and cost out of operations. This is also not really new, but we see increased interest by users of such facilities. Another area that I find quite interesting are cities, public spaces. And so for instance, there's a company in Germany that built a technology using air quality sensors that are deployed around towns and cities, and that allow the city administrators to divert traffic from one route to another if the air quality in, let's say, an inner city, because of a lot of traffic, has gone down, to basically divert it through a different route, and to do that by directly affecting traffic lights to overall improve, first of all, traffic flow and also air quality in the city. That is a virtual city, if you want. And we see more examples like that wherever there are large physical environments or spaces that can benefit from a more fluent operation and improve basically the flow of things.
And what I find fascinating with all of this is the ability to be able to simulate things beforehand. The what if. Well, what if we put traffic down this street or that street, and
Right.
being able to, based on real world physics models, being able to go, well, what's the best way to do it? So it's that simulation capability is key for people to be able to, well, the what if scenarios.
Yeah, that's what this is about, and so we see exciting opportunities in that space, and the next level of that obviously could be on a more regional or even global scale, the simulation of weather pattern, and if you can anticipate weather pattern better, you can entice, you can warn people, you can take other measures to avert catastrophes and so on. So that's an area where we see certainly AI-based technologies being deployed, and where Omniverse can be used to visualize such events.
Well, I know at GTC, was it 2 years ago now, you had it was like a digital twin of planet Earth that you were building, so.
Right. That is still a work in progress, but it is progressing, and we're hopeful that more countries, more regions are going to use that.
Well, it's a fascinating time, and as you say, the advancements in the silicon, in the compute, in the AI, in the language models, the comms, and people looking at it. I suppose that at Hanover, when we were chatting with some of your colleagues there, and a lot of people in the industry, a lot of people are looking at this and the ability to create the digital factory, to train, to simulate, given the lack of skilled workers right across the globe, right? It's got to be a tool you can use to overcome some of this stuff.
Oh, absolutely. And since you mentioned lack of workers, one area we've been engaged in is the German railroads, who are planning to operate more trains autonomously. So they have to establish a virtual model of the railroad network. Now, this is not going to happen overnight, and they are in a relatively early stage of that, but they know that they will not have enough train operators for the flow of the network in the not too distant future, and so more autonomous trains will come, and to operate them safely, we need a digital representation of the network. So they're working on that, for instance.
Yeah, what we talk about at the art of the possible, there's more and more people going, hey, look at the capabilities, and as you say, this isn't going to happen tomorrow. This could be 5-10 years down the line, but that's where people are headed.
Right.
Hey, interesting times.
Yes, absolutely.
Thanks a lot.
My pleasure. Thank you, Kevin.